Welcome to qnawire.
Okay, we have the following molecule. Okay, and then we've got three additional molecules, and we need to figure out which ones of them are enantiomers of this one. So I think something that will be useful is just determining what the stereochemistry of this particular molecule is. Because then we can determine the stereochemistry. We can make sure that the connectivity of the other molecules is the same, determine what their stereochemistry is, and then determine if it's an enantiomer because we've changed the stereochemistry, or if it's maybe the same molecule because it has the same stereochemistry, or when we check the connectivity, we can maybe it's a different molecule altogether. It doesn't even have the same connectivity. So let's start there. I know that on this carbon, I've got to determine what the highest priority group is and what the lowest priority group is, and what the intermediate priority groups are. I know a bond directly to bromine is higher priority than any bond to carbon. So I'm going to call this 1. And now I've got a bond to a carbon with 2 bromines on it, a bond to a carbon with 1 bromine on it, and a bond to a carbon with no bromines on it. So it's actually going to be 2 for the 2 bromines, 3 for the 1 bromine, and 4 for the no bromines. Great. Now, conveniently, we have the lowest priority group in the back, which means we can just determine whether traveling from 1 to 2 to 3 is clockwise or counterclockwise, and then directly find out if it's R or S. This looks clockwise to me, which tells me that this stereocenter has the configuration of R. Okay, so we've got the R form of this molecule. Now let's go through the other molecules and determine whether or not they are in fact the same molecule, because they have the same connectivity and stereochemistry, a different molecule altogether, or an enantiomer. Okay, the first one we're shown is the following. We've got CH3 up here, got our methyl group, got a wedge to bromine, a dash to bromine, a wedge to CHBr2, and then over here we've got our single bromine having carbon. And it looks like our substituents are the same, right? We've got a single bromine carbon, a double bromine carbon, a bromine, and a methyl. So it's at least, either the same molecule or an enantiomer. Now let's determine the stereochemistry. So we've got bromine, which is our highest priority substituent in the back, which means that if we ignore the bromine for a second and just look at the other 3 substituents and determine if they are counterclockwise or clockwise, whichever answer we get, like if we get clockwise, then we know instead of being R, like clockwise would suggest, that in fact it's S. So when we have something other than the highest priority group in the back, that's a little trick we can do, is just pretend that it's, the lowest priority, determine the stereochemistry, and then flip it. Okay, so if we do that, remember we're ignoring bromine for a minute. Not erasing it. We're ignoring this for just a second. And we start to number the substituents. The one with 2 bromines is the highest, 1 bromine is the second, and the third highest is just the methyl. And then that looks like clockwise. But remember, we have to do the opposite of that. So that looks like R, then that means it's actually S. So this is the S enantiomer of the first molecule. Okay, so we got S. Let's put that up here. This is an enantiomer, and it is the S enantiomer. All right, let's look at the next one. Now we've got a bond straight up to CHBr2, down and to the right to CH2Br, a wedge to bromine, and a dash to our methyl. Okay, now once again, as we had in the first case, we've got our lowest priority group in the back. That's methyl, which means we can just number them straight up and count counterclockwise or clockwise. So I see the the Br is the highest. Next is the carbon with 2 bromines. And finally, we've got the carbon with 1 bromine. And this looks like clockwise. Clockwise tells us it's R. So this is not an enantiomer, it's the same molecule, right? This is the same molecule as we had before. Okay, and you can kind of imagine, if we rotated this down and then rotated this back, that it would end up looking exactly like that. So basically, we can get to from the very first structure to the third one just by rotating it, or vice versa. If you built models of them, which is always a good thing to do, but if you did build models of them, you'd see that they're exactly the same molecule. Okay, and for the last one, we've got a bond straight up to CH2Br, down and to the left to bromine, a wedge to CHBr2, and a dash to our methyl group. Very convenient. Once again, we have the lowest priority in the back, so we can just start numbering the highest to the lowest priority. I see the highest priority is bromine, as per usual. Second highest priority is the methyl with the carbon with 2 bromines, and then third is the 1 bromine. And this looks like counterclockwise to me, which means that this has an S stereochemistry. And in all cases, we had either an enantiomer or the same molecule. They never changed the connectivity or anything like that. So this is just an S enantiomer. And if you were curious, yes, that means it is identical to this molecule. You should be able to rotate, if you were to build a model of either of these, rotate it such that it looks like the other one. And that's it.